In this episode of Star Hopping with the Kissimmee Park Observatory, we'll check out the early morning sky and show you how to find these beautiful solar system objects. Comet LINEAR, the planet Mars, and the planet Saturn. All right, let's go star hopping. Hey, hello, hi, and welcome to episode 28 of Star Hopping with Kissimmee Park Observatory. I'm Dave Hearn, and I'm absolutely enchanted to be your host. In this series of programs, we'll show you the most beautiful sights in the night sky and explain exactly how to find them with your binoculars or your telescope. So this week we're going to jump forward a bit in time as there's a lot going on in the southeastern sky in the wee hours. Normally I would wait for the Earth to move along in its orbit some more, but we have another visitor to our solar system, Comet LINEAR, designated as Comet 252P, with the P standing for periodic, meaning it loops around the sun in a very long elliptical orbit and shows up in our skies every 5 years or so. The comet is floating through the constellation of Ophiuchus right now. I captured it with the KPO reflector this past weekend at about 3 a.m. Don't worry, I slept in the next morning. The moon has been in the way until recently, but now it has returned to the evening sky as a crescent, and it's left the morning skies dark. And with that, the visibility of the comet has improved. The comet is now around 6th magnitude, which is barely visible to the naked eye, but it'll be easy in binoculars. Since I have you awake that late, or early as the case may be, I wanted to alert you of a great sight in the morning. Just a little south of the comet, the planets Mars and Saturn have collected in the constellation of Scorpius, and it's quite a sight in the southeastern sky. Scorpius has a bright beacon of its own, the bright orange star Antares. So the trio of bright objects, along with the shape of the scorpion's claws, makes for a really interesting view. So let's learn a bit more about Comet LINEAR right after this.
Star hopping target number 1.
Comet LINEAR was named for its discovering telescope, the Lincoln Near-Earth Asteroid Research 3.5 meter telescope at White Sands Missile Range in central New Mexico. This program watches for any NEOs, near-Earth objects, that are close. And that was definitely the case for Comet 252P. It passed only 3.3 million miles from Earth on March 21st. That's right out in our front yard on cosmological distance scales. The comet appears decidedly green in all astrophotos taken of it. The big round part of it is called the coma, and it's created by the comet's icy core converting directly into gas that ends up trailing behind it in a tail. Mostly the coma is composed of methane and ammonia, but there's another chemical called cyanogen, which when ionized by the solar wind glows green just like a neon sign. A little worrisome part of this is that cyanogen gas is deadly poisonous to human life, but we would have to pass directly through the comet's tail to be affected. In 1910, the Earth did pass through the tail of Halley's Comet, but its cyanogen was so diffused that there was no ill effects to the Earthlings of that era. But many people were convinced that everyone was going to be poisoned, so there was lots of comet parties at that time as the people thought it would be the end of the Earth. So let's locate Comet LINEAR. Here's a plot in SkySafari that shows the comet's retrograde loop. This strange path is caused by the comet's motion overlaid with the orbit of the Earth. The outer planets also exhibit these retrograde loops as Earth passes them in our inner and faster orbital motion. So at the time this video is coming out, the comet will be just to the upper right of the 3rd magnitude star Cybele, otherwise known as Beta Ophiuchi in the constellations of Ophiuchus, the Serpent Bearer. But we'll be starting from the brighter star Rasselhag, which shines at magnitude 2.1. So you're going to start out by moving 8 degrees to the lower right to Cybele. Now move about 3 degrees to the upper right to a 5th magnitude star. You're very close to the comet, which will be only slightly fainter. Now move about 1.5 degrees to the upper left, and you'll see the hazy glow of Comet LINEAR. This comet will be visible even in the smallest of telescopes and binoculars, so it should be pretty easy to locate. Once you've found it and you know how it appears in your eyepiece or binoculars, you can go out a week later and see how it's moved. I noticed that the position moved even between my 2-minute exposures when I captured it the other night, so this guy is really trucking along. Well, now that you've found the more challenging target, let's move on to a much easier one, the planet Mars.
Star hopping target number 2.
Mars has always captivated people with stories of aliens coming from the Red Planet in great movies like H.G. Wells' War of the Worlds. But we've learned a lot in the last several decades with man landing 2 rovers on the Red Planet, Spirit and Opportunity. I was really impressed by this recent image from Opportunity that showed a dust devil skirting across the Martian surface. We're living in amazing times with these robot explorers. So Mars is the most prominent point of light in the southeastern sky, beaming at magnitude -0.1. It's moving toward its May 22nd opposition when it's at its closest approach to Earth on this side of the Sun. So this will be a great opportunity for you to use that high-power eyepiece of yours in your telescope. The smaller planets require a huge amount of magnification to be able to see any surface features because the planetary disks are just so darn small. For example, the Moon is about a ½ degree in size, which fills a wide-field eyepiece. That's 30 arc minutes, as there's 60 arc minutes in a degree. Something like a large globular cluster like Messier 13 that we talked about a couple weeks ago is only about 4 arc minutes across. Still pretty seeable in a medium magnification, say 100 power or so. But these planets, geez, when Mars comes to opposition, it will be just 14 arc seconds across. There's 60 arc seconds in 1 arc minute. So converting the size of M13 to arc seconds, it would span 240 arc seconds across. Mars will only be 14 arc seconds wide. So M13 is 17 times larger than Mars. Do you get the gist of this challenge? So the process will be center Mars in your low power eyepiece, then change it out for medium magnification. If you can still see it clearly, swap it out for your high power eyepiece. If the atmosphere is still, you may be able to make out some of the markings on the surface of the planet. But if it's not, it'll look like a round orange ball at the bottom of the swimming pool. Here's a great map of the features of Mars, courtesy of Sky and Telescope. So now let's look at a little bit of a larger target in our solar system right after this.
Star hopping target number 3.
So Saturn is loved by everyone who sees it through the telescope. At public observing sessions, I've been accused of having a little model of it hanging inside the telescope because what people see looks so amazing in the scope. Saturn and its rings are definitely one of the most unique and spectacular sights you can view through a telescope. We're lucky right now because the rings are almost fully open from our perspective in space. In this configuration, it's easy to see the shadow of the rings on the planet and even the spaces between the rings themselves. Add to that the motion of the Saturnian moons that orbit the planet, and even sometimes cloud bands on the planet itself. It's an amazing sight. Saturn is also easy to locate with the unaided eye, shining brightly at magnitude 0.3. It's a little bigger than Mars at 18 arc seconds across. And comparing to M13 as we did with Mars, it's 13 times smaller than M13, as opposed to 17 times smaller. But the rings give you a much better target, and as you increase magnification, the sight is much more pleasing to the eye. Saturn lies about 8 degrees to the left of bright Antares. You can see the color difference between Saturn and its orange companions. Mars and Antares look very similar in color, but Saturn is much more yellow. So let's review. Now that you've completed your solar system observing session, you can either go back to bed or just drink coffee until the sun comes up. Well, while you sip, you can review in your mind what we saw. First off, we checked out Comet LINEAR, moving along its retrograde loop in Ophiuchus. Then we moved about 10 degrees to the right of the summertime constellation of Scorpius and admired the 2 planetary beacons, Mars and Saturn, as they dance with the bright red giant star in Scorpius, Antares. If you have your camera, this would be a great wide-field shot to capture. If any of you get a chance to image this celestial scene, send us your shot and we'll share it with everyone on next week's show, and we'll give you a shout out for your effort. So that does it for this week's episode. You can find the show notes on our website at kpobservatory.org/sh028, where you can comment and leave any questions that you may have. Well, thanks for joining us, and I'll see you next week in our episode of Star Hopping.
I'm Cassie, and I hope you've enjoyed star hopping around the Milky Way. We'll continue to bring you these video astronomy tutorials every week on Thursday, and in their podcast format on Fridays. They'll be designed to help you find deep sky objects that are up in the sky at the time we post them on the internet. The reason we create these videos and podcasts is to help beginning amateur astronomers learn the sky and get more enjoyment out of their telescopes and astronomy in general. If you have any requests for potential targets in the night sky that you would like to see us discuss, just let us know down in the comments section below or on our website blog. Don't miss our free field notes for this episode, basically the script of the show, with all the images and star charts we use for our star hopping activities. You can get them for free at kpobservatory.org/fieldnotes. If this is the first time you're checking out star hopping, and if you found this video useful, please consider subscribing to our channel by clicking the big yellow button, click the thumbs up on the video, and please share this tutorial out to your friends who like looking at stars. Also, as I just mentioned, please feel free to leave any question or comment below, and we'll be sure to respond quickly. Please follow KPO on Facebook, where we post all of our astronomical digital images, and keep everyone informed about upcoming astronomical events. We'd love to hear from you to discuss all this great stuff up in the sky. All the links to these places in cyberspace, including our website, kpobservatory.org, can be found below in the episode notes as well. And finally, if you feel this video provides you value, and if you'd like to see more, please consider supporting us on Patreon, where for a small amount per video, you can support our efforts, and help us make even more great astronomy tutorials, just like this one. So bye for now, and thank you for watching, and we'll see you next time on Star Hopping with Kissimmee Park Observatory.